We came 100%. We are going to varsity. We are going to varsity. Destination is varsity. Destination is varsity. Varsity. Destination varsity. Destination is varsity. We see 100%. We work 100%. We try 100%.
Subscribe to our channel, like our videos, turn on the notification button because the destination is varsity. Yes. The finals of 2015. Okay, so they are saying here, you are literally given, let's highlight what's given here. So they're saying you literally have a graph. Okay. You literally have a function g of x, which is following this equation that's given here, right? Now they're asking you to write down the equation of asymptotes of g. This shouldn't be really hard because we've learned that the asymptotes generally, this is a hyperbola. So let's solve 4.1. So generally, in a hyperbola, you literally have your f at x being equal to a over x plus p and then a plus q. Just to clarify something, when your a is greater than 0, if your a is greater than 0, that means your graph is in the first and the third quadrant. But if your a is less than 0, that means your graph is in the what? In the second and the what? And the fourth, if your a is less than 0. So yeah, to clarify that, because in the other lecture, I think we said it the other way around. So yeah, thanks for those who picked it up. It shows that you guys are great students. You are very brilliant. Okay, let's delete this because it's, oh my gosh, technology. Delete and delete. Okay, so you know that if you wanna determine the x asymptote, you literally say x plus p should be equal to 0. Therefore your x should be equal to minus p, right? And then if you want to determine the y asymptote, you literally have you equate that to q, sorry. So what's your value of q here? You literally have your p being 2 and your q being minus 1. So you now know what's the equation of your asymptotes. So in order to write this in a form of equations, you literally have to say x plus 2 equals 0. Therefore, x should be equal to minus 2. And y should be equals to what? I think that was minus 1 if I'm not mistaken. Yeah, it was minus 1. How do you know this is an equation? This is an equation because it says x equals something. So that's an equation. Y equals something. That's an equation. So you just backed yourself 3 marks there, hey? Okay. So what's the next question? Calculate the y-intercept and x-intercept. Okay, so it start by, let's go to 4.2. Let me write nicely beneath that one. So it'll be 4.2.1. For y-intercept, you let what? You let x be equals 0. You have then, I think there was g of x, so it's g of 0 equals, let's go back to our equation again. It's 6 over x plus 2, so it should be 6 over 0 plus 2 minus 1. And that's more equals 6 divided by 2. That's 3, that's equals 2. So therefore the y-intercept becomes 0 is to 2. Why am I adding 0? Because we say it for y-intercept, you let x be what? Be 0. So that's why your x is 0. And you determined your y to be 2. So that's your y-intercept. That's where the graph touches the what? The y-axis. Okay, let's go and determine the x-intercept. Okay, so they're saying now, to determine the x-intercept, what do you do? 4.2.2 for x-intercept, you let y be equal to 0. But you know that your g of x is still another form of writing 0. So your g of x then equals 0. So therefore 0 is equal to what? Let's move our page up a bit. It's 6. It should be 6x plus 2 minus 1, right? And then you take your 1 to the other side, right? That's how you solve mathematics. You take this one to the other side, ne? Okay, therefore it will be 1 equals 6 over x plus 2. Then you just kill your, not kill per se, but you get rid of your denominator by multiplying by its both sides, ne? Multiplied by what? X plus 2. Then you'll know that this will cancel with this. Then you'll be left with this on this side. Anything multiplied by 1 will yield that thing again. So it's x plus 2 equals 6, ne? Therefore, your x-intercept will then be equal to what? You'll take what? You'll take this 2 to the other side because you want to group the like terms, right? So that means your x-intercept will be equal to x equals 6 minus 2, which is equal to 4, which therefore be equal to 4. You say the y is what? Is 0. So you've bagged yourself some free marks again. Then now they are saying, what are they saying now? They are saying, you see here, they are saying draw the graph of G, clearly showing the asymptotes and intercepts with the x's. You know, in this instance, let's maybe erase this so you'll be able to note this. You know, in this instance, you know that your a is what is greater than 0. So that's your that means your graph is somewhere in these quadrants. Ne? That means now it's a matter of determining which asymptote is this one and which asymptote is this one, and then plotting those intercepts, ne? With the x's. Okay, let's go down and plot our graph. That's 4.3, right? 4.3. I think we'll need a bit of a space, so we plotted a cute graph. Not a cute, but you know, it's always better to do things to your best ability. Okay, let's see if we can, never mind the shape, it should be x here and y here. Before we move further, let's maybe touch on, label our points clearly, starting by the asymptotic lines. So where our asymptotes? We said x should be what? X should be what? X should be what? Minus 2. And still y should be minus 2. That's what we got. Is this our asymptotic line? Let's go back. Which question was this? X minus 2. No, we made a mistake here. Thanks for it should be equal to minus 1 here. Minus 1. Then this should be equal to minus 1. I don't know where I got minus 2. But I'm glad that most of you are going to recognize that, right? We're going to recognize that. So this should be what? This should be minus 1. So that's why it's always better to go back and re-revise your work. Not revise per se, but double check. Because you see, I think I said minus 1, but now I'm saying I wrote minus 2. I don't know from where, but yeah. You do make those mistakes, but you have to rectify them. And it boils down to practice, and practice again. Okay, cool. So it's minus 1 and minus 2. Let's go down again and label those points in our graph. Okay, so that means you have minus 1 somewhere here. Okay, let's maybe go down here. And you have minus 2 somewhere here, right? Oh, you have minus 2 here and minus 1 here. Okay, does this make any sense? Yes, it does. Maybe let's write it like this. Minus 2 should be maybe somewhere here, and minus 1 should be relatively closer. Perfectionists worldwide. That's the beauty of mathematics. You can tell if you're making a slight error, and you'll be like, does this make sense to me? No, it doesn't. Let me think. What am I getting wrong? Because you're heading to 100%. You don't want to lose easy marks, right? Okay, cool. Let's then solve our beautiful problem at hand. So you know that this is an asymptotic line, right? This is what? An asymptotic line, right? This is an asymptotic line. And this is also what? An asymptotic line. It doesn't touch there, it doesn't touch there. In high school, you used to say asymptinti. Asymptinti. That's Zulu classes for you. It doesn't touch here, asymptinti. It doesn't touch here. Okay, maybe we should enlarge our x's. Our x's. Okay, cool. Let's go and check for our intercepts. For our x-intercept, it touches at 4 is to 0. That's somewhere along here, maybe. Let's just put it here for argument's sake. Let's say it's here. This is number 4, point number 4, okay? And then your y-intercept, where is your y-intercept? Your y-intercept was 0 is to 2, so it touches here. Let's maybe put it here for argument's sake, okay? I mean, I'm not a drawer, so if the lines are not straight, apologies, but you get the point. So that means now your graph should also touch here, right? And touch here, right? It'll look something like this. It doesn't touch there, and then it'll look something like this. But you know that it should be also in the what? In the third quadrant, because your A is what? Is negative. Your A is what? Negative. So you can just draw something like this. Just to mimic what is in the what you call first quadrant. Yeah, generally that's how it should look, but you can draw it nicely. I mean, yeah, you guys are good at drawing. I mean, I shouldn't be judged. Hey? I shouldn't be judged. Number 4, determine the equation of line of symmetry that is a negative gradient in a form of this. So now when they say line of symmetry, they're talking about a line that's more like a reflection, that gives a reflection to your graph. So this graph is reflected at this point, right? Like when you draw a line, a straight line passing through this point, like a straight line passing through this point, you see on the either side of this line, you literally have, well, this should be similar to this, like this shape should be similar to this other shape, right? But I mean, it's my drawing, but you get the point, right? So they're now asking us to determine the equation of this line. This line always is a gradient of what? A gradient of magnitude 1. Depending on the shape, if it's facing like this, therefore the gradient of this line is what? Is -1, right? Right? Okay. But if it was this way, the gradient of the line was going to be what? +1. So it always has a positive or a negative gradient which has a magnitude of 1. Yeah? When I say magnitude, I mean size, because magnitude is what? Okay, never mind. I wanted to explain it in terms of scalar quantities and vector quantities. So it has both magnitude and direction. I mean, this is not physics. We'll touch on physics when we get there, but it's still mathematics now. Okay, cool. So when they specify that it should have a negative gradient, you see here what they're saying. They are saying that has what? A negative gradient. You know that gradient is -1. It can either be 1 or -1. So if my graph was this way, that means that line was going to have a positive gradient, you know? Or it's going to have a positive gradient, which is going to be 1. Eh? But you can still draw a graph like this, then they ask you to determine a line of symmetry that has a negative gradient. You just know that they're asking for a line like this. You focus on the fact that is it having a negative or positive gradient, then use the point of intersection to determine the C value, right? But we'll get there shortly. Before I confuse maybe some of you. Let's go down. Where is our x's or our asymptotic? Where are they meeting our asymptotic lines? You see, they're meeting here at this point over here. They're meeting at this point over here, right? And what are the coordinates of this point? It's what? -2 and -1, right? So you know that my line is passing through -2 and -1. So what number was that? Was that 4.4? Here was 4.4. So now that means for you to solve 4.4, You just need to do the simple thing. 4.4. Okay, use black because we've been using block. 4.4. You know that m is equal to minus 1 because they said negative gradient, ne? Negative gradient, ne? Given. This is more like given, ne? It's given. But you know that means your y equals mx plus c boils down to y equals what? Y equals what? M is what? Minus 1. So it's going to be minus 1 times x is minus x, then plus c. But you know that this line passes through minus 2 and minus 1. Eh? So therefore, if you plug in x, y, you'll get minus 1 equals minus into minus 2 plus c. Okay, we're solving for c now. We're solving for c. Therefore, it will be minus 1 equals 2 plus c. Therefore, you'll have to take this to the other side. It will be what? C equals 2 minus 1 minus 2, right? Because you're taking this to the other side, it will change sign. Therefore, your C. Therefore, your C will be equals minus 3. It says it's going to be equals minus 3. Let's see if this is making any sense. Yeah, it makes sense because you see that this line over here, when you look at it, it passes through a certain point here, and that's less than minus 1. So it should be something less than minus 1. So it's minus 3. You see, because your C is more like a y-intercept. Ne? The value here is minus 3, right? Makes sense to me. I haven't checked the memo. You'll have to do that and double check with the memo. I wonder why people are calling me when I'm conducting a lecture. No, you shouldn't call me when I'm conducting a lecture. Okay, let's go to 4.5. Okay. Have we really written down the equation? These people are disruptive. They're disruptive. They wanna disrupt us from getting 100%. So this is the equation, eh? This is the equation of the line that they're asking you to determine. Okay. Let's go and solve 4.5. For which values is this thing over here? They're asking for which values is this thing over here greater than or equal to this thing over here. What are you realizing here? This is your graph, ne? Let me use a red pen because red is dangerous and we're about to grade 100%. Why am I saying great now? This is your graph. And then this is what the equation that you just determined, your equation of symmetry. So what are they asking you? For which values of x is your graph either greater than or less than your equation? Greater than or equal to the line of symmetry. Okay. Let's go back to our drawing. Where is our graph greater than or equal to greater than or equal to the line of symmetry? Okay, where is that? You see on this side, when you look at this side, when you look at this side over here, okay, when you look at this side, let's just look at this side. Your graph, the y values of your line of symmetry are always greater than the y values of your graph, ne? Because your graph is literally where it's literally here, ne? So if you take a y value, let's say this x value, you know that your line of symmetry will have your y value that is greater than of the graph, ne? So that means that this value f at x, was it g? I think it's g of x is greater than the line, ne? Is less than the line, ne? At this from this x value all the way downwards. But if you move from this x value all the way upwards, are you seeing that your line is now sitting here? Let's say this x value, your line is now sitting here at a lower x value, right, than your graph. So that means that this x value, your graph is now, your g of x is what? Greater than your line, eh? But the question now is asking us, for which x values is your graph greater than or equal to the line? In my humble opinion, I think this question was not phrased correctly. They should have said greater than, because there is no point where your graph is equivalent to the line, because your graph doesn't touch this point. Like, there's literally no point in my humble opinion. Hence, I strongly believe they should just say in their memo. I haven't checked the memo. I might be, saying things from my head, but because I'm an independent thinker and I speak my mind, I think the answer to this should be x should be greater than -2. But maybe in their memo they have x greater than or equal. I mean, this doesn't make sense to me. I think this is the correct answer. So I urge you to go to the memo and comment in the comment section. Be like, okay, this was the correct answer. Daddy, you got it wrong or I got it right. I mean, I was just using my mind. But I'm training you guys how to think. Because looking at the memo and thinking that you've got it, it doesn't really help. Doesn't really help. So this is how I would solve these questions. Ne? We'll have to go through the memo sometime and see how much am I getting. Because we're in the road to 100%. If I had lost any mark, I'll feel very bad. So it'll be your duty to correct me, right? Okay. Let's just delete this because we're done with this question. Okay, now let's proceed to this exponential function question, which says you have to solve for a if this graph has this equation and there's this point. It's simple. So you literally say 5.1. You have a point which is 2:9, right? You must know this is x and this is your y, right? Therefore, f at x, which is equal to a to the power of x, right? Then you know this is also y, right? So you literally plug in 9 equals a to the, this is 9, and this is a to the power of 2. Yeah? You make the left-hand side similar to the right-hand side. So it should be 3 to the power of 2, a to the power of 2. Therefore, your a should be 3. Ne? A should be equal to what? A should be equal to 3. Your a should be equal to 3. That's how you solve the first question. And then the second question, we asked to determine the equation of g if g is equal to. So they're saying 5.2, it says you literally have g of x equals f of negative x, right? And then you know that your g of x will then be equal to, whenever there is x, you plug in what? You know your a, so whenever there is x, you plug in negative x, then you're done. And let's go to 5.3. 5.3. It says determine the values of x for which f prime. So no, this is not f prime, it's more like the inverse. What is an inverse? An inverse, if your x, you have xy, it turns into yx, ne? So that means now you have your x being 2 and y being 9 here, right? So that means this point will turn into 2, 9 is to 2 in your inverse. That means wherever, the inverse of an exponential flows like this, ne? So that means there is a point which has an x value of 9, and then the y value will be 2. So anything greater than that x value will literally yield a y value that's greater than or equal to 2. Therefore, the answer to this one should be x should be what? Greater than or equals to 9, eh? Right? But maybe one would want to solve with the long root, and they'll be like, okay, let me first determine the inverse of f at x. You know that f at x is 3 to the power of x. That means f inverse of x, you swap in what? You swap in x and y, so it will be x equals to 3y, ne? And then you introduce your log, ne? Log base 3 on both sides. And then, yeah, you also introduce what? You also introduce log base 3 on the other side, ne? Will be 3 to the power of y, ne? And then if you know your log rules, you should know that now this should be giving you your inverse function as what? As log base 3 of x. Yeah? Why? Because this base here, you literally get an answer of y on this other side. So this is the answer. That's your inverse function. So now they're asking you, when will this inverse function be greater than or equal to 2? So I would then say log base 3 of x greater than or equal to 2. How do you undo this? You know that for your exponent to be left alone, you need to have what? You just need to have okay, let me phrase it this way. You remember what we did it here, what we did here. We killed 3 to the power of y to be y by introducing log base 3. That means if you were to undo this thing here so that you get rid of that, you would be left with x greater than or equal to 3 to the power of what? 3 to the power of 2. That's how you'd undo. So this thing is also similar to this. So therefore your x would be greater than or equal to 9. I mean, that's a longer route. I wouldn't prefer it. So I'd prefer this route. Which literally says using your graph, as we used our graph over here to determine the thing. Okay, let's delete all this and then solve 5.4 for 5.4. Sorry, 5.4. Delete. Let's clean our page. Let us clean our page. Let us clean our page. Let us clean our page. Okay. What is 5.4 is so simple. It's asking if your inverse is a function. Oh, yes. It is a function. Why? Because it looks like this. For every x value, there is only one y value. That's how you know if thing is a function. For every x value, there is only one y value. Ne? But if it was not a function, it was gonna look something like this. Let me delete this. It was gonna look something like this. You see, there is only one x value, but there are two y values here. This is not a function. For a function to be a function, x value should only have what? One y value. One would ask me, is the parabola a function? Then yes, it is a function. Why? Because for every one x value, there is only one y value in a parabola. How? If a parabola was to look like this, you see this x value always corresponds to this y value. This x value always corresponds to this y value. You know, there's like, yeah. But when you plot a function like this x value corresponds to two y values. This is not a function, man. Okay, cool. Yeah, we're done with this segment. So we'll take another problem. The graphs f at x equals ax squared plus bx plus c, where a is not equal to 0. Because why are they specifying that a is not 0? They're trying to tell you that your a can never be 0. Because if your a, let's say you have like f at x equals ax squared plus bx plus c, and let's say your a is equal to 0, that means you have now f at x being equal to 0, x squared plus bx plus c, right? Are you noticing that this will literally fall away, right? Because anything times 0 is equal to what? Is equal to 0. Therefore, your f at x will end up being equal to bx plus c. Isn't this a straight line function? More like, I mean, your straight line function is equal to is y equals mx plus c. So your B in this case can be literally correlated to the gradient. But yeah, they're specifying that this is not equal to 0, such that they emphasize to you that this is a parabola. A parabola. Parabola. Okay, let's go. Vamos. They said so. Spanish boys, they say so. Vamos after scoring a goal. And G, which is that equation over there, are drawn below. D is a common point between F. Okay, sorry, not between, on F and G. So that means this is a point of what? Of intersection. Okay. How do you determine the point of intersection? You know that at the point of intersection, your F at X is equal to what? G of X. That's what it's literally saying. What do you mean by saying this? That means the Y value obtained by plugging in the equation of F at X is equivalent to the Y value obtained by plugging in the equation of what? Of G of X. That's what the point of intersection means. So yeah, I'm just enlightening those who might need enlightenment. But yeah, those are just basics that you have to have in mind, that you need to know before solving these questions. G is a tangent at D. Okay, G is a tangent at D. Tangent of F at D. Okay, one thing that maybe you need to know is that the tangent of a quadratic function is determined by taking a derivative of the function. I'm just stating these things so that even if they come in the questions, you know how to solve them. So a tangent at any point, you know, in a straight line function, your gradient is what? Is equal to y2 minus y1 all over x2 minus x1. Maybe I was saying like incorrect terms. What I meant to say was that a gradient at any point is determined by what? By taking a derivative of the quadratic function. Maybe I said a tangent, but I can't recall clearly. How do you take what you call the derivative? How do you derive? So generally, when you derive, if you have x to the power of a, how do you derive this? You literally say the derivative of this. Let's say this was your f at x, ne? The derivative of this, you say f prime x. That's how you denote that you're now taking a derivative. You multiply by this thing. You multiply the coefficient that is here by this thing. So that means you'll be having 1 times a, which will literally be a. Then you return your x as it is. Then you minus 1 from the exponent. So it will be a minus 1. Let's put this into practice. Say now you had like x cubed, ne? Or x squared or something. Let's say your f at x was equal to x squared. What is the derivative of this? F at x, f prime x is equal to, you multiply by this, you multiply whatever is in here by the exponent. There will be 3x, then you minus 1 from the exponent squared. Simple as that, right? Let's complicate it a bit, not complicate per se. Let's say now you had f at x being equal to 3x cubed plus 6x squared plus 4x plus 6, ne? How do you determine f prime of x? The same logic applies. You just take what? You take this and multiply this with that. So it'll be 6. Then you retain your x. Then you minus 1 and the top will be 1. You don't normally write 1, but you can if you want to. But if you write x like this, we know there's a 1 here, there's a 1 here. Generally, we don't write those, okay? Then the same thing plus this times this, 6 times 2, it's 12, minus 1x. Oh, sorry. Was this squared? Okay, it's fine. I should have said cubed. It's fine. Huh? Wait, I think I'm conflicting myself. No, I'm not. I said 3x squared, 6x squared. It's fine. I should have just united these and, like tens. But I meant to say cubed here, but it's fine. I mean, the same logic was going to apply. You're going to say 3 times 3, which was going to be 9. Then minus 2 is going to be squared. But it's fine. Then you see 4x. You have a 1 here, right? 1 times 4, it's 4. Then you return your x, ne? After returning your x, you literally say 1 minus 1, that's 0. You still write your 0, right? Then now, when you look at this, you don't have an x here. You have just a 6, right? You just have a 6. What does this mean? It literally means that you had an x to the power of 0, right? Anything to the power of 0 is 1. Okay, 6 times 0, that's 0, ne? No, maybe I'm conflicting this. Let's just stick to the rules. Let me not try to be a super mathematician because I'll mess up maybe this, right? But generally, you'd say 6 times 0, that's 0. Then you minus 1, that'll be what? X, then minus 1. But anything times 0 is 0. Then that's why they say a derivative of a constant is 0, ne? But yeah, okay. That's not your final answer, but it is low-key your final answer. You can leave it like this, or you can sum up these terms to like 18x plus 4x plus 4. Sorry. This was okay. Because anything to the power of 0 is 1, so it's plus 4, ne? Yeah, so you can't leave your x to the power of 0. Okay, I just formulated this from my head. Apologies if someone was lost somewhere. You can literally track it backwards and then try and make sense of what I was saying. Why am I saying all this? I'm saying this so that you guys are aware of the fact that if you want to determine the gradient of a what? Of a parabola at any point, you need to take what? A derivative of that gradient of that parabola. Say in this case, if you wanted to determine the gradient of this graph at this point, you will take a derivative of this function, which will then be equal to f prime of x. In this case, was going to be equal to what? To ax plus b. Ne? Then you plug in the x value that corresponds to this point. That's how you are going to determine what? The gradient of this graph at this point. In this case, you have a d here. If you wanted to determine a gradient at this point d, you are going to use this same equation, which is literally the derivative, and plug in the x value of 1. Why is that useful? In this case, you see that you have a tangent now here. You literally have this tangent over here, right? So you know that the gradient here, the gradient at the point of the graph at the point of intersection with the tangent is equivalent to the gradient of the tangent. So that means the f prime of x at point D, ne, is equivalent to the gradient of what? Of g, ne? In your linear equation, you literally have what? Y equals what? Mx plus c. If you wanted to determine this gradient here, you'd literally take a derivative of this function at this point, plug in the x value at this point, then get a value. That value is going to be equivalent to what? To your m here. And then you plug in the value. You literally have your 1 is to minus 8. This is your x, this is your y. You plug in these values over here, ne? Over here to determine the value of c. Now you have the equation of g. I haven't really solved this problem. I was just thinking out loud. Maybe if someone doesn't know these things, so you know them, so that it doesn't feel like I'm freestyling when I'm solving the actual problem. Okay, let's dive in deep to solving the problem. I like it when you attack when you attempt problems, because we end up learning not new things but new things, if you get my point. Okay, let's solve the problem. For which values of x is f at x less than or equal to 0? This is very simple. What do they mean? What is f at x? F at x is this graph, ne? They're asking you this graph over here. For which values of x is this graph in the positive y zone? It's positive here, right? If you go this way, and it's positive if you go this way. It's negative if you go this way, ne? It's positive here, it's negative if you also go this way, it's negative, ne? So from this point upwards, it's positive, and from this point upwards, it's what? Positive. So one can say 6.1, my x should be what? less than or equal to minus 3, and my x should be what? Greater than or equal to 2. Because they said less than or equal to. If they had said f at x less than 0. Oh wow, did I answer? Okay, I'm answering something else in my mind. I'm saying they said greater than or equal to. Okay. So that means now you literally have to. Okay, let's restart. Okay, I was answering a different question in a different question. Okay, cool. Never mind. Let's solve. Let me. Okay. In this case, they said less than or equal to. So what I was answering f at x greater than or equal to. So when is my f at x less than or equal to? They mean like when it's negative, right? You need to double check your work. You see, these mistakes, if you don't make sense of your work, you'll end up losing marks unnecessarily. You need to make sense of your work. You see, now I haven't even checked the memo. I can tell that no, I made a mistake because I try and make sense of my work, right? Okay, so that means your x is between these two values, 2 and what? And minus 3. So it'll be like less than or equal to minus 2, greater than or equal to what? It's plus 2 here, minus 3. Ne? So it should be greater than or equal to minus 3, but less than or equal to what? 2. Positive 2. Okay. 2 less mistakes. I'm praying now. Hey, God, make me do less mistakes because we're heading to 100%. Okay. Now they're saying determine the values of A, B, and C. A, B, and what? And C. Okay. How would you go about that? I mean, you don't have to panic if you see this type of questions. You see, even I at this point, I'm like, how would I solve this? But what do I know? Okay, I know this point, and that point. I'm looking for 3 values, ne? So that means I can literally plug in all these points and formulate 3 equations. Okay, but before I do that, let me just write down it's 6.2, right? I know that maybe let me zoom out a bit, like, oh my gosh, our thing just disappeared. Where is our equation? Okay, it's here. It's over here. Okay, 6 point what? 6.2. Okay, how would I go about solving this? So you literally have your f at x equals ax squared plus bx plus c, right? The first point is what? Minus 3 is to 0. And then the other one is 2 is to 0. And then the other one is what? That's your point D, right? 1 is to minus 8. Ne? Okay, let's start. These are xy's, right? Okay, let's start by plugging in this point. Ne? You know your x is minus 3, but your y is 0. So that means you'll have a minus 3 squared plus b minus 3, then plus a what? Plus a c equals 0. Okay. I'm thinking to my head, at some point, I'll need to eliminate this, not eliminate per se, but make these subjects of the formulas. Okay, cool. That means now you'll have 9A. Hey, my A and 9, they look kind of similar. Okay, minus 3B plus C equals 0. Okay. If you now plug in this x value, what are you getting? You'll get, let's say this is like your equation 1 or something. Yeah? What are you gonna get if you plug in that x value? You'll get a into 2 squared plus b into 2 plus c equals 0. That means you'll have 4a plus 2b plus c equals 0. Okay, Okay, maybe let's say this is your equation 2. Now, if you plug in this point over here, the last one, point D, what are you getting? You know your D is 1 is to minus 8. You'll have A into 1 squared plus B into 1 plus C equals minus what? Minus 8. That means you'll have your A plus B plus C equals minus 8. Okay, let's say this is your equation what? Equation what? 3, ne? Okay. I'm just thinking in my mind, I'm like, let's convert equation 3 into equation 4. So we eliminate C in all our equations, ne? Let's say convert equation 3 into equation 4, ne? How? By making C subjects of this formula. That means I'll take all this onto this side, ne? Therefore, my newly formed equation will be C equals minus 8 minus A minus B, right? Okay. This is now my equation what? Equation 4. Okay, because I wanted to eliminate B. I want to eliminate C. So that means now I'll have to plug in, substitute equation 4 in equation 2 and 1, right? Wherever there's C in equation 2 and 1, I need to plug in equation 4, right? Okay, let's go. I'm saying substitute equation what? Equation 4 in equation 2 and equation 1, or equation 1 and equation 2, whichever order. I mean, it's mathematics, we're not doing English. So, okay, cool. That means, let's start with equation 1 for simplicity. It's 9A minus 3B plus C. Okay, so that means now you'll have your 9A minus 3B plus C, but you know your C is what? Minus 8 minus A minus B, then that's equal to 0. Simplify this. 9A, that's literally you saying 9A minus A, that's literally gonna be your 8A, right? Minus 3 minus this minus 4B minus 8 equals 0. Ne? That's you subbing equation 4. Let's use subbing equation 4 in 1. Ne? Let's use subbing equation 4 in 1, right? Okay, now let's sub in equation 4 in 2. What was our equation 2 saying? Equation 2 was saying, if you look clearly, like here, what was our equation 2? It was 4A plus 2B plus C equals 0. 4A plus 2B plus C equals 0. That's your 4A. Or you can literally say this is your low-key equation 5-ish, ne? Because now you have a different equation now. Okay, what was our equation 2 saying? Let's go and look. It's 4A plus 2B plus C or something. Yeah, 4A plus 2B plus C. 4A plus 2B. But your C is what? Minus 8 minus A minus B equals 0. Then let's simplify. That's literally gonna be your 3A minus plus B, ne? Plus B minus 8 equals 0. That means you now have your equation maybe 6-ish, ne? You literally have equation 6-ish. Which one is the simplest between the two? When you look at these equations, I think this one, it's relatively easy to make B subjects of the formula here than making any of these two subjects of the formula. So, because I'll literally have to take this guy and this guy, both of them to the other side, right? Okay. Let's now, what is this? Let's just delete you. We don't need you. We don't need you in our lives. We've moved on with life. Okay, let's convert equation 6. Equation 6 to what? To equation 7. Eh? Equation 6 to equation 7. By making B subjects of the formula. That means now you'll have your B being equal to 8 minus what? Minus 3A. Ne? That's your equation what? Equation 7. Ne? Then To eliminate B now again, you'll have to sub in equation 7 and equation 5, right? Wherever there is what there is B, you literally plug in equation 7. Ne? You have your, let's say, sub equation 7 in equation 5. Ne? Then you literally have your, what was equation 5 saying? 8a minus 4b minus 8 equals 0. So it's 8a minus, I think it was minus 4b. Let's confirm again. Minus 4b, but your b is now 8a, 8 minus 3a, right? I think it was minus 8, but let's just double check again. Minus 8 equals 0. Equal to 0. Ne? Okay. Now let's solve for a here. You literally have your 8a. 4 times 8. 8, 16. I think that's 32. Minus 32 plus 12a minus 8 equals 0. This is 20. Ne? That's like 20a. This is like 20a, and this is like minus 40 equals 0. Okay. And then you take maybe this guy to the other side, so you left only with the constants this side. So you literally have, let's be consistent with our colors. So you literally have your 20a equals 40. Divide by 20 on both sides. Why am I not consistent anymore? I said I should be consistent, right? You literally have your 20a equals 40. Then you divide by 20, divide by 20. This cancels. 2 divided by 4, so therefore your a is equal to 2. Does this value of a make sense to me? Let me go back to my equation, so I see if I'm still on the right track. Or maybe to the original problem. Or the graph is facing upwards. Ne? The graph is facing upwards. So my a value should be greater than 0. Is it greater than 0? Yes. I'm thinking. I haven't checked the memo, but I'm thinking that I'm in the correct line. Ne? I'm heading in the right direction. Okay. Now let's for b. For b now we want to determine b, right? For b sub a. In which equation? I think it's equation 7, but let's confirm what b is the subject of the formula. You see here, b is the subject of the formula. So it's sub a in what? In equation 7. In equation 7. Therefore, b, okay, let's stick to our red color because we are dangerous. Therefore, b is equal to, okay, what was b equivalent to? What is b? 8 minus 3a. So it's what? 8 minus 3 times 2. That literally says 8 minus 6, which is equal to 2 again. Oh, we're getting 2's here, hey? Okay. Then for C, what do you do for C? For C, sub A and B in equation. Let's confirm where is C subjects of the formula, okay? This is the equation where C is subjects of the formula. You see here, equation 4. In equation 4, okay, sub A and B in equation what? In equation 4. In equation 4. Therefore, oh my gosh, I wanna be red because we are dangerous. Therefore, C is equal to, let's go back to our equation, it's minus 8 minus A minus B. C is equal to minus 8 minus 8 is 2 minus B it's 2. Therefore, my C is equal to minus 8. This is more like minus 12. Ne? Okay, let's confirm if this value of C makes sense, because C is more like our y-intercept, right? More like our y-intercept. It's minus 12. Let's confirm if it makes any sense. Okay, we see that our graph touches the y-axis at a point here, ne? But we have a point D, which is like minus 8 here. Minus 8. You see, our y-intercept can't be minus 12 because minus 12 is less than what? Minus 8. So you now have confidence that I'm thinking that this 5 marks is mine. Eh? If I had made any calculation or error, correct it when you're doing this problem. But I'm just teaching you logic here. I want you to be able to master these questions and solve them like nobody's business. That literally means now, when you conclude your question, you just be like, therefore, okay, let's say, therefore, okay. You'll be like, therefore, A is equal to 2, B is equal to 2, and C is equal to minus 12. Like at the bottom of your working, right? You'll be like that, C is equal, these are your answers. I'm just writing anywhere because I have a privilege of erasing. But in your exam type of situation, you want to write your things in an orderly manner. Ne? Okay, let's just erase this before we maybe, let's maybe select all. How do we delete all? Delete. Yes. Power of technology. Power of technology. Okay. Now they're asking us to determine the turning point of F. The coordinates of the turning point of F. Remember, this was 6.3, ne? We're solving 6.3 now. You can either use this equation minus b over 2a, or say, I mean, it's up to you. You remember that a straight line like this has a gradient of 0, right? If a line is straight, it has a gradient of 0 because the y value is not changing. So that means y2 minus y1 is literally 0 because y2, y1, y2 is literally the same y value. Like the y value doesn't change in a horizontal line. Why am I saying that? I'm saying that so you guys are aware of the fact that at the turning point, the gradient is 0 because the tangent is more like the horizontal line here, right? It has a constant y value. Unlike here, the gradient is not 0 because this graph is not a what? The tangent is not a horizontal line, right? Okay. So you can use either this guy over here, this method, to determine the x value. Remember the equation that we developed. Or you can use the fact that at the turning point, your derivative, your gradient is what? Is equal to 0. Okay, let's solve it using this method first. This one is quicker. Minus x is equal to, that's the x at the turning point. That's how you determine the x value of the turning point, right? Minus b, you know your b was minus 2 all over 2. A was 2. That means you literally have what? I think it's the x there is minus 0.5 or minus 1 over 2 or minus 0.5. Does this x value make sense? To me, it kind of does because it's at the negative side, right? So your x values here are negative and it's closer to 0. Okay, let's solve it again using the derivative method. You know that your f at x is equal to a. Your a was equal to x squared plus 2x minus 12, right? Okay, what is your f prime in this case? You literally have 2 times 2, that's your 4x plus 2. Then you equate this to 0 because at the turning point, your derivative is what? Is 0, right? Then you solve for x from here. So what does it mean now? You take this 2 to this other side, and then you divide by 4 at the end. You'll still get the same answer. You'll be having 4x equals minus 2 divided by 2 divided by 4 divided by 4. This cancels, this cancel. Therefore, your x at the turning point is equal to what? Minus 0.5 or minus 1 over 2, depending on how you want to put it. Ne? Then, from there, you're not done, really. You're really not done. So how do you then solve the whole question? Because they're asking you to determine what? The coordinates. I'll leave that to you. You know, you have f at x equals 2x squared plus 2x minus 12, right? Minus 12. Now you know that the x value at this point is what? Minus 1 over 2. Just plug it in here, and determine the y value. I don't have a calculator with me, so I don't want to end up, but it seemed like yes, because it will be f at minus 1 over 2 is equal to 2 into minus 1 over 2 squared plus 2 into minus 1 over 2 minus 12, right? You know, this will be minus 1 over 4, that literally, oh, it will be 1 over 4, then it will be 1 over 2 here, I guess. And then minus 1 minus 12, no? Okay. I might get something incorrect here because I'm using my head. Maybe 1 over 2. This is f at 1 over 2. Then it's literally 1 over 2 minus 13, minus 13. So that's more like 12.5 minus 12.5. Does this make sense to me? You remember this point over here, the tangent, the y-intercept was what? Was 0 is to what? Minus 12. You remember the c value. But the turning point is just below that. So it's minus 0.5 into minus 0.5 into minus 12.5, right? So it makes sense to me because it's slightly below the turning point. So I'll be confident enough to say I'm still on the track of getting 100%. But do it yourself and see if you're getting the right thing, or we're getting the same thing. If I'm not getting the right thing, refer to their memorandum. I think this was taken from 2015 question paper. But don't refer to the memo before attempting, right? Okay. Now they're saying write down the axis of symmetry of H. If H is this. Okay. Ooh, interesting. Okay, what are they saying? If H is there, write down the axis of symmetry. What are axes of symmetry? It's more like they're asking you the new value of the what? Of the oh my gosh, of the turning point, because this is where this your graph is divided into two equivalent parts. What are they saying now? You remember this x value, the x value here was what? Minus 0.5. Assuming that we calculated things correctly, because I was using my head. So you need to use your calculator and refer to, maybe the memorandum or something at some point. But I'm teaching you how to think here. Now they are saying your f at x is what? Your h at x is what? F at x minus 7. What does that mean? According to my logic, they're saying this graph is shifted to the right 7 times. So that means this point will be now located at x equals 9 and 0. That's how I understand this. This point will be located at 9 and 0. So that means this point now, that was minus 0.5, will be now located at what? At 6.5, because you just add a 7. So I think, from my head, the new equation is x equals to 6.5. That's what I think. That will be the new turning point, like the axis of symmetry, like will be literally at x equals what? 6.5. But if you are not sure, what you need to do is, but that's a longer route. That's a very, very long route. You can literally say, I know my f at x is equal to, but that's very wrong. That's very long, not wrong. X squared plus 2x minus 12, right? Then what is f at x minus 7? It will be equal to 2 into x minus 7 squared plus 2x. Oh, sorry. Plus 2 into x minus 7 minus 12, right? Then you rearrange this such that it literally becomes, it turns into a form of ax squared plus bx plus c, right? Then you'll be like, okay, now you have this. Then you'll be like, again, what is f at x minus 7? F at x minus 7 plus 2. So that means in this equation, after rearranging this, you add a 2 again. And then from that equation, you'll now be having your h at x, right? Your h at x in a form of ax squared plus bx plus c. And then from there, you can use this equation. There's this equation for axis of symmetry, which says it's more like you're determining the s value of your turning point. It will be like x minus b over what? Over 2a, right? Your new value of b, you plug it in here. Your new value of a, you plug it in here. Or you can say, once you have your h at x, to determine the axis of symmetry, you literally say, again, your h at x will be in the form of x squared plus bx plus c, right? Then you say h prime of x at the axis of symmetry, because that's where it's literally turning. That's your turning point. You determine the x-coordinates of your turning point. That will be your axis of symmetry, right? But that's very long. That's very long. In my mind, I'm just like, okay, it's shifted 7 units to the right. This one is not really important because the axis of symmetry don't change along the y-axis. This is like a vertical shift. What I'm more concerned about, what? The horizontal shift. I'm more concerned about what? The horizontal shift, right? Okay, I want to delete. Okay, so that means in my mind, I'm literally more focusing on this guy over here because they're saying the new equation for the axis of symmetry. This one is not really that significant according to me, but you guys need to double check with the memo because I'm using my head here. I'm using my head. Ike is using his head. Okay, and then now calculate the gradient of G. How do you determine the gradient of G? It's simple. 6.5. We've solved this before even knowing that they'll ask us this question. You determine the gradient of this graph at any point by taking the derivative. And you'll be literally, the derivative will be 4x plus 2, right? Because it is literally derived from f at x equals to x squared plus bx plus, why am I saying bx? Because now we have our value of b. It will be 2x minus 12. And the derivative of that boils down to what? To this. And then to determine the gradient of G, you know that the gradient of G is equal to f prime at 1, right? It's what? At 1, because this point is also in G, but the gradient of at this point is equivalent to the gradient of what? The gradient of f at this point is equivalent to the gradient of a tangent passing through this point. Né? F prime at 1, which will literally be 4 into 1 plus 2. That's literally 6. That's a gradient of G. Né? You literally have your 15 marks just like that. If I made any mistake, correct with the memo. Don't come and chow me. Or correct me in the comment section or something. We are wasting any time. Let's solve this one. This one, it says in the diagram below, the graph f at x. Okay, I don't like it on it. Yeah, let me use this one. In the diagram below, the graph, yeah, I love this one. The graph f at x is drawn in the interval f at x equals x squared. Is drawn in interval x. Okay. I'm thinking this graph is drawn in only in the negative interval. Maybe it was gonna proceed like this because it's a parabola, I guess. Ne? So that means my a is less than 0, hence it's facing downwards. So if my a is greater than 0, it's gonna what? Well, it's gonna be facing upwards according to the lessons that we had. Ne? Okay. Now they're saying the graph or the inverse is also drawn. P is a point on F. Okay. And R is a point on this. Okay. Is F the inverse a function? What is a function? If something is a function, that means only one y value should one x value should correspond to only one y value. So as I said, or as we said before, this is a function. This is a function. Why? Because this x only has one y value. But this is not a function. Why? Because this x has this y value and this y value. So how to check if your function is a function, if your graph is a function? If your function is a function, you draw a vertical line. If it cuts your graph only once, that means there is a function. Let's see our vertical lines in this domain. It only cuts this graph only once, right? So this is a function. Why? So my answer will be yes. Yes, it is a function. Why? Because there is only one y value for every x, for every x value. For x, or for all x values, or for whatever, but you get what I'm saying, ne? There's only one y value for my x values in the system, ne? Okay, I wanna delete technology, please. Okay. Yeah, so we're done with, we have our 2 marks. Well, let's mark for ourselves. If R is a reflection of P along this line, let's try and draw. I'm not sure if we'll be able to draw this one. My handwriting, or my, hey, got you. This is a straight line. This is like a reflection straight line, eh? But what do you know? Like, it's just a saying, determine the coordinates of R. It's simple, because your R is more like, they're now saying P, R is an inverse of P. So whatever was X will turn, because if you're determining an inverse of something, it turns into what? Into YX, ne? So that means your coordinates of what? Of R are literally, instead of having -6, you have -12. Instead of having -12, you have -6. Those are coordinates of R, because you just swap the X and Y values. Calculate the coordinates of A, the value of A. Okay, you literally have your f at x equals ax squared. This is your 4.3, right? This is your 4.3. Your f at x equals f at x squared, but you have this point, right? So your f at x, this is your x, this is your y, right? So you have your -12 equals, your a is what? Your x is -6 squared. What is 6 squared? I think it's 36. So that means you'll have -12 equals a into times 36, right? Then you divide by 36 both sides. You divide by 36 both sides, right? And this will cancel. Okay. What is 12 divided by 36? My math. 6, 12. Okay, let me use it like in terms of 6. 6, 12. 6 goes twice here. 6, 12, 18, 24. Then 24, then 30, then 6, 12, 18, 24, 30, right? 36, that should be 2/6 equals A. In simplest term, will be -1/3. I think this is your A. If I made any mistake, use your calculator, man. I'm just using my head, so yeah. Okay, cool. Let's just delete this. Let's delete this. Okay. And then 4.4. Write down the equation of the inverse. It's simple, because when you write down the equation of the inverse, you must know that your x, y, and then the original function turns into yx, ne? But you know that the f at x is equal to -1/3 x squared, right? So that means now this is also equal to y equals -1/3 x squared. That means now your inverse, ne, would literally be x equals, this is -1/3 y squared. Then you multiply by 3 both sides, 3/1, then multiply by 3/1. Then you'd literally have your y squared equals -3x. Then you take a plus or minus square root. Okay. Then you literally have your y equals plus or minus square root of -3x. Are you done? Let's ask ourselves, are we done? Once I see a plus or minus, that's not fine. But you literally told that you're only considering this part where y is negative, right? So the part that's applicable here, I think you say therefore y is equal to minus 3x. But since there's also a negative somewhere, I want to specify that for when x is less than or equal to 0, as they specified here. I think they specified somewhere here, right? Because you want to make sure that your equation is literally mathematically friendly. By saying mathematically friendly, it means it aligns with mathematical guidelines. So that means your inverse function will be literally equal to minus 3. Oh, sorry. It will be minus square root of minus 3 for when x is less than or equal to 0. So this is your final answer. This is how I would answer this question. Dango is thank you. Let's delete all. We're done. I think this is our last question. So we proceed to the next section, which is literally, whatever section is proceed. I think it's derivatives. That's so nice. But for now, that's just our last section. Because you need to practice by yourself at the end of the day. Practice. We're just teaching you how to think along those things. Then you practice. If you do question papers, just do as many questions as you possibly can, because metric only comes once in a lifetime. So make it count. This is your final grade. You've been working very hard, so you want to make sure that you exit high school in style. And it's so nice when you look back and be like, I made myself and those who love me proud. So give it your all. Let's solve this question now. F and x equals, okay, they gave us this equation, and then you have to solve the coordinates of A. This is more like a hyperbola, right? It is a hyperbola. Not it is more like it is a hyperbola. Hey, what are you doing? Okay, it's here. Okay. So how do you then solve this? You're literally gonna say, they're saying write down the coordinates of A. Revert to this. You remember a hyperbola is ax plus p plus q. Then the what you call the asymptotic lines will be represented by minus p and q, right? So that means here you have a minus p and here you have a q. What's your minus p? That means you have a 4 here, right? X minus 4 equal to 0. Therefore, x is equal to 4. And q, you take it as it is, which is equal to 3. So that means you have a 3 here. Where are they meeting? They're meeting here at A. Therefore, the coordinates of A is what? 4 and 3. No? Makes sense. So calculate the coordinates of what? They're saying we should calculate the coordinates of what? Of B. How do we calculate the coordinates of B? What is B? B is the y-intercept. For y-intercept, you let x be 0. So that means you have f at 0 equals 6 over 0 minus 4 plus 3. That's literally going to be f at 0 is equal to 6 over 4 minus 6 over 4 plus 3. Therefore, f at 0 is equal to 6 divided by 4. What is that? 2 minus 3. 2, 4, 6 minus 3 over 2 plus a 3. You can use your calculator to determine the answer, but I enjoy thinking, so let me try and use my head. So f at 0 is equal to minus 3 over 2. Let me write this as a 2, 4, 6. Is a fraction which has a denominator of 2, so it will be 2 here. Therefore, f at 0 is equal to LCD, yes, 3 over 2. What is 3 over 2 in fraction form? It's 1.5. Therefore, f at 0 is what? 1.5. Therefore, my coordinates is of B at 0 is to what? 1.5. Right. I feel so proud of my thinking capabilities because, it's so nice to not use a calculator, because you're trained to think if you're not using a calculator. A calculator can make you a bit dumb, trust me, because you'll even fail to calculate 1 plus 1 when you overuse a calculator. A calculator is designed to make people dumb. So I suggest if you can, Yeah, in your exam, use your calculator because you want to be sure. But when you're still practicing, train to use your mind because this will literally prepare your head for things that requires like thinking. Your brain will be used to thinking and solving problems. So, yeah. Okay, the coordinates of C. This is what is C? The x-intercept. You let y be 0. So that means you'll have your 6. This means you equate this thing to 0, right? 6 minus 4 plus 3 equals to 0. Take this to the other side. You have 6 to x minus 4 equals minus 3 multiplied by x minus 4 on both sides, x minus 4 on both sides. This will cancel with this, and then you'll be left with 6. You'll be left with what? With 6 equals minus 3x plus 12. Okay, then you take 12 to the side, you'd be having minus 6 equals minus 3x. Therefore, your x will be equal to what? Your x will be equal to 2. Your x will be equal to 2, right? So that means the coordinates is of B, it's 2 to 0 because your y was what? Your y was 0. Okay, simple as that, simple as that, simple as that, simple. Hyperbola is so simple though, like they hardly conflict you here. It's just straightforward questions. Write down the coordinates. Oh, those were coordinates of C, not of B. Coordinates of C, 2 is to 0. C was, I think it was 0 to 1.5, no? Okay. Okay, agree. Okay. What? Did I just delete the did I just delete the question? Okay. Let's go back and see if we can. Okay, we now here's our question. Okay. Let's delete you. How do I delete you again? Because you keep on writing yourself. How do I delete you again? Danko. Okay. Now they're saying calculate the average gradient between what? Between B and C. Average gradient between this point and this point. You know this is what? 0 is to 1.5. And this is 2 is to 0. This is your x2 or x and y2, x1, y1. We calculate the average gradient as if you're calculating a gradient of a line passing through these 2 points, like a straight line. So that will literally y2 minus y1 all over x2 minus x1. It will literally be y2 is 1.5 minus 0. What did I say? My y2 is this one. I said this is my point 2. It depends, but be consistent. So my y2 will be 0 minus 1.5. My x2 will be 2 minus what? My x2 will be 2 minus what? Minus 0. So it will be literally be what? Be minus 1.5 divided by 2. Right? Yeah, I'd like to think so. You can use your calculator to solve this further, but I would leave it like this if I'm pressed against time. But I know that, let me just think again. 1.5 is like 3 over 2, right? 3 over 2, right? Divided by 2. That means you'll have 3 over 4. That's like 0.75. But that's minus. Up to you. Use a calculator. I mean, I'm not here to develop new calculators that will stick in your heads, but use your calculator because you're allowed. Okay, so determine the equation of a line of symmetry which has a positive y-intercept. You literally, this is very tricky. One would think the line of symmetry will always have a gradient of either 1 or minus 1. Depending, if they say positive gradient, you take this gradient, you plug it in this equation, mx plus c. If they say negative gradient, you take this gradient, you plug it in this equation. And then to determine the value of c, you plug in the point of interception, right? But now they're saying positive, not gradient, but y-intercept. So that means that line is passing like this, né? Okay, so that means it's passing through which point? What's the value here? It was 4 and 3 if I'm not mistaken. Let's go back. Yeah, it's 4 and 3. Okay, so that means now you have y equals x plus c. But the point that this graph is passing at is 4 and 3, right? 4 plus c. Therefore, wait. You see, it's even tricking me now. They said positive y-intercept. That means your gradient is negative. Be mindful of that. I was trying to notify you of that, and it tricked me. Oh, this is so funny. So this is minus c. So it's minus 4. Therefore, your c will be what? Will be 7. Therefore, the equation will be y equals minus x plus 7. Yeah? Okay. You can double check if this is correct by plugging in the value of x, maybe of this point in this line, on this line. See if you're getting 3. Yes, you are getting 3. Therefore, you're correct. Yeah, I think this is the last type of function. I mean, you can always do proms. But if you're stuck somewhere, email info at destination varsity.com. Info what? Info at destinationvarsity.com. You'll get more assistance there. Yeah, if you stuck somewhere. But this is relatively simple. Easy marks that are up for grabs. Danko is thank you. I think we'll meet by derivatives now. I'm tired of doing these questions because they're so simple. They're not even challenging. Yeah, bro.
It's 100%. We work 100%. Destination varsity. Destination is varsity. We are going to varsity. We are going to varsity.
Thank you for watching. Like, comment, and subscribe to our channel.